Let's take the function sine of t minus 2 times u of t minus 2. Here is the graph of sine of t. We know that the sine of 0 is 0. To get the graph of sine of t minus 2, we have to shift the graph of sine of t by 2 units to the right. So we have to shift this graph by whatever this number is. So basically this here will have the same shape as this graph. Now this makes sense because, for example, if we work out the value of this function at t equals 2, well, we plug 2 in for t, we get sine of 2 minus 2. Well, that's just the sine of 0, which is of course 0. So at t equals 2, this function is 0. Just like at t equals 0, this function here is 0. Let's suppose we work out this function at t equals 3. Well, we get sine of 3 minus 2. We plug 3 in for t, which is the sine of 1. So we get the same value for this function at t equals 3 as we do for this function at t equals 1. So these two values are the same. So again, that makes sense if we consider that the graph of sine of t is shifted to the right by 2 units. Now here is the more general situation. The sine of t minus a is got from the graph of sine of t by shifting sine of t a units to the right, assuming here of course that a is positive. If a is negative, we have the reverse situation. We would shift the graph of sine of t by a units to the left. Now in this example we also have the function u of t minus 2. Now we saw in the previous video that u of t minus 2 is a unit step function where the step occurs at plus 2. So at 2, the value of u of t minus 2 is 1. And the function is equal to 1 for values of t greater than 2. For values of t less than 2, the function is 0. So we're multiplying 1 by sine of t minus 2 for values of t greater than 2. That just gives us the graph of sine of t minus 2. But we get 0 for the graph of sine t minus 2 when we multiply it by 0. In this example, we're going to sketch the curve e to the power of t times ut minus 1 minus ut minus 2. Now the graph of ut minus 1 is a step function where the step occurs at plus 1. It's 0 for values of t less than 1. The function u of t minus 2 is a step function where the step occurs at t equals 2. So it's equal to 1 for values of t greater than 2, so it'll coincide with the graph of u of t minus 1. But we saw in a previous video that when we take the difference between u of t minus 1 and u of t minus 2, we just get a line segment from 1 to 2. This part cancels out because it's equal to 1 for both functions. So the graph of ut minus 1 minus ut minus 2 will be 0 for values of t greater than 2, and it'll be 0 for values of t less than 1. So here I'm showing ut minus 1 minus ut minus 2 in red. And the dotted curve indicates the function e to the power of t. So we need to multiply this red function by the curve e to the power of t. Well, we have 0 here for this function, so 0 times anything is 0, so we're going to get 0. Ut minus 1 minus ut minus 2 is 1 for values of t between 1 and 2, so we have 1 times e to the t. Well, that's just going to give us e to the t, so we're just picking out the part of the graph of e to the power of t for t between 1 and 2. And then for values of t greater than 2 we have 0. So we have 0 times e to the t, which is 0. I'm trying to show this to scale here. Well, both scales on both axes are different actually. E to the power of 1 is the value of this point. e to the power of 1 is about 2.7. So this point is actually above this point, but it's not drawn to scale.